hybridization. Hybridization means the mixing of atomic orbitals of having same or nearly same energy of same atom to form equal number of new orbitals having same energy and set is known as hybridization. Then, how sp hybrid orbitals are formed? Sp hybrid orbitals formation. One s atomic orbital is a mix with one p atomic orbital of same atom to form two sp hybrid orbitals. I shown here diagrammatically. This is the z axis, this is x axis, and this is the y-axis. This is the s orbital. You know that it is spherical in shape. This is the x-axis. This is the y-axis, and this is the z-axis. This is the pz atomic orbital. And that forms two equivalent hybrid orbitals. This is the one. This is the second. This is the x-axis. This is the z-axis, and this is the y-axis. This is the two sp hybrid orbitals. This bond angle is a 180 degree. here plus, 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 minus. This is the plus, minus, minus, and plus. Then second, SP hybridization. One is atomic orbital. This is x-axis, this is z-axis, and S atomic orbital is combined with 2p atomic orbitals. This is the x-axis, this is the z-axis, and this one is the y-axis. That forms how many? That is the hybrid orbitals, three, which are equivalent one. This is the first one. This is the second one, and this is the third one. This is the large lobe, and this one is the small lobe. This angle between the two hybrid orbitals are 120 degree. This is the 3sp2 hybrid orbitals. Then third one, sp3 hybridization. One s atomic orbital x, y, and z and y axis plus three p orbitals. First one, this is the second one, this is the x-axis, this is the z-axis, and this is the y-axis. That forms, that is the 4sp3 hybrid orbitals, 4 1. Then that becomes, this is the first one, this, this one is the second, and this is the third one, this you see four sp3 hybrid orbital 3p atomic orbitals. Then, what is the silent features of hybridization? You know already. Silent features of hybridization. First one of the electron one of the electron from an orbital in the ground state configuration of atom get promoted to the next available orbital of higher energy, resulting in an excited state configuration with appropriate number of half filled orbitals. And second, the number of hybrid orbitals formed, the number of hybrid orbitals formed is equal to the number pure atomic orbital which undergo hybridization. Third is that the energy release during formation of sigma bond by overlapping of hybrid orbitals is higher than energy release by formation of sigma bond by overlapping of pure atomic orbitals. Yes, therefore, sigma bond formed by overlapping of the hybrid orbitals are more stable than those formed by pure orbitals. And fourth one, which is very important, hybridization involves atomic orbitals of the same atom. Fifth one, the electronic charge in hybrid orbital is concentrated more in one direction. This leads to a better overlap with orbitals of other atoms. Hybrid orbitals always sigma bonds and contains contains lone pair of electrons. Hybrid orbitals never forms pi bond. The stability of bond formed by the hybrid orbitals is due to excessive overlapping of orbitals provided by them. These are the silent features of hybridization. Then we discuss here calculation of the coefficient of AOS used in hybridization. Before going to use that quantum mechanics to the hybridization concept, we discuss here first in concern with some terms involved in that quantum mechanics. First, we know that what is the psi. Psi gives only amplitude of wave. You know that electrons are travels in the form of the waves, and that have also that is the particle properties. Then if it is forms of waves, then psi indicate that amplitude of the wave, and that have no physical significance in a quantum mechanics. It has no physical significance. Then in concern to psi square, yes, psi square have that is a physical significance. That psi square shows that is the probability of finding of electrons in particular point, supposed to be here, like that. Yes. Then I square d phi. If it is a small value, this is a small value, in which that what is the probability of that electron, that is the psi square d phi is the probability of finding the electrons in particular point in small volume d phi. Then you know that yes, d phi is equal to dx into dy into dz. Therefore, this becomes psi square d phi is equal to psi square dx dy into dz. It is the probability of the finding of the electron in a particular point in a small value. But if you this extend it to the three-dimensional Cartesian axis, this is the probability of the finding of electrons in three-dimensional axis. Then suppose to be this space is a very large. This space is a very large, and that becomes a three-dimensional. This is the z-axis, this is the x-axis, and here is the electron. And what is the probability of that electron in a three-dimensional space? Yes, that can be measured by integrating the equation minus infinity to plus infinity psi square dv, and that always equal to 1. That is the condition for normalization. This is the very important. And if the multiplication product of the probability of the finding of the electron in three-dimensional space, that always equal to 0, that is a condition of the orthogonality. Yes, this is very important if you want to derive wave equations for the different hybridization. Then next point, calculation of the coefficient of AOS used in hybridization. Then wave functions of the hybrid orbitals are obtained by taking linear combination of the angular wave functions of the appropriate atomic orbitals. The wave functions for the hybrid orbitals are obtained by taking linear combination of the angular wave functions of the appropriate atomic orbitals. Hybrid orbitals which are formed from linear combination of S and P. And suppose you want to find out wave function for the ith number of the hybrid orbitals formed, or ith number of the hybrid orbitals formed from S and p atomic orbitals is given by equation. Therefore, the wave functions for the ith hybrid orbital formed from the s and p atomic orbitals is given by phi I is equal to AIS plus BI PX plus CI PY plus DI PZ. The coefficient AI, PI, CI, and DI can be determined can be determined from the following rules. Rule number one, each wave function is normalized. That is AI square plus BI square plus CI square plus DI square is equal to 1. Then second, each hybrid orbital in the set of hybrid orbital must be orthogonal to the other hybrids. That is AI into AC plus BI into BJ plus CI into CJ plus DI into DJ is always equal to 0. And third point is that the square of the coefficients of any component atomic function sum over all the hybrids in which it participates must be equal to unity. That is summation of I AI raised to 2 is equal to 1. With the help of the above rules, the following procedure is employed to generate equivalent hybrid orbitals. By using these rules, the following procedure can be implemented to generate equivalent hybrid orbitals. First one, choose the Cartesian coordinate system and place one of the ith hybrid orbitals along one of the coordinate axes and as many of the others orbitals as possible in the plane containing this axis and other coordinate axis. And second one, since S orbital has a spherical symmetry, therefore each equivalent hybrid orbital of a set contains 1 by n of the total of the unit S orbital distributed in n hybrid orbitals. Hence, the coefficient in each hybrid orbital is 1 by root of n. These are the primary requirements to construct the wave functions for hybrid orbitals. Next time, we will discuss the construct the wave function for sp hybrid orbitals. Thank you. Thank you so much.